Chapter 2, Section 2 is called Logic, and that is a new class that our school is offering, actually. Mr. Montague started teaching it this year. The two of us went to a training on it, and it was pretty fun. Let's see here. I am going to share my screen with you and talk to you about logic. So, again, starting in the book, starting on page 99, which is the first page of Chapter 2, Section 2, if you notice, Chapter 2 doesn't really feel like math. Most people think of math as arithmetic or algebra, but this is actually math because it's logic, it's conceptual, which is also why I save it for December because it's a little bit more fun. Here we go. So we're going to talk about a statement, which I know you've heard of that word. You've heard of the word truth. You've heard about compound statements. I'm guessing all of those. Okay. But for geometry purposes, a statement is a sentence that is either true or false. The truth value of a statement, when you say that, what is the truth value of the statement? You're asking if the statement is true or false. That's how it's worded. Okay, statements are often represented by the letters P and Q, P or Q. So P, this statement P, and at this moment, is a rectangle is a quadrilateral. So if you think about it, what is the truth value of that statement? The truth value is true. Okay. If you put the negation of a statement, that's like saying the opposite truth value. Okay. The negation of a statement has the opposite meaning as well as an opposite truth value. And it's represented by, look, this little squiggly. If you put a squiggle in front of the letter P, that's saying not P. That's how you say it out loud. You don't say squiggle P. You say not P. So not P, if P is still the statement, a rectangle is a quadrilateral, then not P is a rectangle. A rectangle is not a quadrilateral. And now the truth value is false. For real. Okay. So there's two words. Oh, well, one more thing. If you put two or more statements together, it's called a compound statement. And there's two types that we're going to talk about in this section. There's going to be a conjunction or a disjunction. So first here they talk about a conjunction. Using the word and is called a conjunction. If you put two statements together with the word and between them, it's called a conjunction, okay? And so if P is still a rectangle is a quadrilateral, and now they made up some other one, Q, a rectangle is convex. Do you remember that we talked about convex and concave in chapter 1? Convex are like what you normally think of as quadrilaterals. Rectangles are not concave. They don't cave in on themselves. So rectangles are convex. So in case you didn't remember what that meant. A lot of the examples they're using are a means to help you review things that we've learned so far this year, or maybe algebra. A rectangle is convex. Truth value is true because it is not concave. Okay, so if we put P and Q together, you literally write out the statement for P and the statement for Q, and you put the word and between them. That's how you do it. And there's another symbol that they could use. Here we go. Let's see here. The conjunction of P and Q can also be written like this little symbol right here. This is the symbol that means conjunction, and it also can be pronounced and think about it, it looks like it's going to be the word and. That's a mnemonic device that might help you remember it. Okay, so it says here, a conjunction is true only when both statements that form it are true. So in this case, this example they give you, a rectangle is a quadrilateral and a rectangle is convex. Since both statements are true, then the conjunction itself, the whole statement, P and Q, or the conjunction of P and Q, is also true. Alrighty. It's pretty abstract. Here we go. And then before I go over examples, I'm going to tell you what the other word is. So there's conjunction, and then on page 100, at the top, they talk about disjunction. Disjunction is when they use the word or, all right? Or is called disjunction, a compound statement. Okay, now look, we have a different P and a different Q. And that's what they'll do. They'll make up statements, random. Sometimes it's math, sometimes it's just a statement, and you have to decide if it's true or not. So P, Malik studies geometry. Well, I don't know if that's true. That's why they didn't list the truth value here. Q, Malik studies chemistry. So P or Q states that Malik studies geometry or Malik studies chemistry. A disjunction is true if at least one of the statements is true. So if he studies either geometry or chemistry, the disjunction is going to be true, even if he studies both, okay? Disjunction P or Q is also written like this, okay? So I don't have a good way of helping you remember that one. I know that it looks like a U, and another word for disjunction is union, but I don't need to introduce yet one more word for you. I do remember that disjunction it uses the word or because I don't know why this works for me, but I say this, it's either this or that. I don't know why I like that, but the summer when Mr. Montague and I were taking the logic class, I would do that in my head every now and then. I'm like, okay, this one is or, and so it's called a disjunction. That's really silly. Let's immediately erase that. Never happened. Oh gosh, I'm recording. Okay, blah. Okay, so, wow. So disjunction. So between those two, that's how you write it. Now let me show you some examples. Oh wait, before I go to the examples, at the bottom of page 100, it has a little summary of the vocabulary. Negation is just what you think. It's like the word negative, a statement that has the opposite meaning and a truth value, opposite meaning and opposite truth value of the original statement. It's written like this. Here's the symbol, and it's read not P. Conjunction, a compound statement formed by joining two or more statements using the word and. Remember, this kind of looks like it's going to be a capital A for and. P and Q. Okay, it could be read the conjunction of P and Q, or you could also read it as P and Q. That's why they're telling you how to pronounce these new symbols. The third symbol is this V. This is like an upside down V. This is a V, but it means or. P or Q is how you read it, or you could also read it as the disjunction of P and Q. A compound statement formed by joining two or more statements using the word or. Okay. Now the videos, hang on, oof. I am going to share some videos with you, and they're the videos that the book offers. I like them. Again, so when you're in the geometry book, okay, when you're in the book, at the bottom of the page, it's that, well, to me, I think it's purple, and it looks like it's a thought bubble, and that's when you click on that, you can see the tutor. Well, let me show you. If you click on that, then you get to the tutor page, and it's your personal tutor. There's also a Spanish personal tutor. I'm going to use these three. I'm not going to assign you any problems that have to do with constructing truth tables because your digital electronics teacher does an excellent job of getting you to practice truth tables. So we're not going to do that in geometry. We are going to talk about the truth values of conjunctions, the truth values of disjunctions, and then how to use a Venn diagram. Okay, here we go.
This is Mrs. Dawson. Truth values of conjunctions. Use the following statements to write a compound statement for each conjunction. Then find its truth value. Explain your reasoning. P. A hexagon has 6 sides. Q. 5 is an integer. R. 7 plus 4 equals 15. P and R, not R, and Q. also read as the conjunction of not, are, and Q. Let's begin with the first one. Statement P is a hexagon has 6 sides. That statement is a true statement. A hexagon does have 6 sides. Now we're looking at the and. P and R. The statement for R is 7 plus 4 equals 15. However, this statement is false. So we have a true statement and a false statement.
Remember that for a conjunction, it's only going to be true if both statements are true.
Although P is true and R is false, that makes P and R a false statement. Because of the and, both pieces would have to be true. The second statement is the conjunction of not, are, and Q. So we're going to negate are, which means
Remember that negate means to have the opposite value. So think about what you think they could do to make 7 plus 4 equals 15 be the opposite of that statement and see if you're right.
we use green for R. 7 plus 4 is not 15.
That's it.
The original statement was 7 plus 4 equals 15. That symbol negates it, which gives us 7 plus 4 is not equal to 15. And this is a true statement. Okay, we're looking for the conjunction of these two statements. So we'll use an and. Q has a statement, is black for Q. 5 is an integer. 5 is an integer.
In case you don't remember what integers are all of the counting numbers and their negative,
5 is definitely
and it also
an integer.
includes 0.
So this is also true because we have not are as a true statement and Q as a true statement. That means that the conjunction of not, are, and Q is also a true statement.
Awesome. Okay, here we go. Whoops, there goes my dogs. Hang on, mouse. Okay, the next video I want to show you, having difficulties here. Oh, there we go. It has to do with truth values of disjunction.
Hello, this is Mrs. Workman. Use the following statements to write a compound statement for each disjunction. Then find its truth value. Explain your reasoning. P. Complementary angles have a sum of 90.
The truth value of P is true.
Q. 25 plus 100 equals 75.
The truth value of Q is false.
R. Vertical angles are a linear pair.
I hope you know that one. We learned it in chapter 1. We reviewed it in chapters 3, and we've reviewed this a few times. That's not true. Vertical angles are the ones that are opposite each other. Linear pair are adjacent.
Before we begin, let's recall a fact about disjunctions. For a disjunction to be true, at least one of the statements making up the disjunction must be true.
At least
the first one we're to consider is P or R. P says that complementary angles, and I'm going to use some abbreviations, have a sum of 90, or are vertical angles are a linear pair. That's what the disjunction looks like. Now let's consider the truth or falsity of its
Actually,
parts.
just write it out with the word or between.
Complementary angles have a sum of 90. That's true. Vertical angles are a linear pair. That's false. Since there is at least one statement in the disjunction that is true, then the disjunction itself is true. And we're ready to move on to the second one. And we read this Q or R. Q states that 25
You could also read that as the disjunction of Q and R.
plus 100 equals 75. Or R, vertical angles are a linear pair. "25 plus 100 equals 75 is false. Vertical angles are a linear pair is false. Since both statements are false, the disjunction is false. The last example is read, not Q or P. Q says 25 plus 100 equals 75. Not Q says 25 plus 100 is not equal to 75. We've negated it. Or P, complementary angles have a sum of 90. Let's check the truth or falsity of each statement. 25 plus 100 is not equal to 75. That's true. Complementary angles have a sum of 90. That's true. So at least one of the statements making up the disjunction is true, and so the disjunction is true.
All right, and then we have Venn diagrams.
This is Mrs. Dawson. The following is an example on using Venn diagrams. Travel. The Venn diagram shows the travel methods for people in a particular company who travel for business. A. How many people travel by plane and train? B. How many people travel by plane or train? And C. How many people travel by plane and not train? Let's begin with part A. How many people travel by plane and train? The blue circle represents all the people that travel by plane. The yellow circle represents all the people that travel by train. The overlap of the blue circle and the yellow circle is 9. That is the number of people who travel by plane and train. In this case, we were looking for the intersection of the two sets. 9 people.
And when she said the word intersection, it was specific because the word and is a conjunction, and it also has to do with the intersection of two sets. And it's true only if both are true.
Travel by plane and train. Part B. How many people travel by plane or train? In this case, we are looking for the union of the sets. There are 25 people who travel only by plane, 9 people who travel using both planes and trains, and 11 people who travel only by train. To find the union of those sets, we will find the sum of all three numbers. 25 plus 9 plus 11 is 45.
And you add them all together because it had the word or, and that's the union of the sets. The word disjunction is also applicable, and it's true if at least one of them is true. So that's why you use all three of them.
There are 45 people who travel by plane or train.
Both.
Part C. How many people travel by plane and not train? The blue circle represented the people who travel by plane. The overlap, or the intersection, represented the number of people who travel by both. 25 is the number of people who travel by plane and not train.
And to reward you, if you're watching this all the way through, if you write the answer to this question on your paper, I will give you bonus points. The question is, what does a right... Oh, I just gave away the answer. What does a 90-degree angle say?